Good morning, everyone. Welcome to your math class. Our lesson for today is about Lesson 14-1, Solid Figures and Nets, textbook pages 707 until 712. Today's objective is to identify nets of solid figures. But before we start, please prepare the following: your math textbook and your pen. Let us first define some important terms used in the lesson. So we first have solid figures. So what are solid figures? So solid figures are three-dimensional figures that has length, depth, and height. So let us compare what is a solid figure compared to a plane figure. So when we say flat or plane figures, we refer to squares, circles, triangles, and so many more like rectangles and parallelograms. What about solid figures? So these are examples of solid figures. You have here rectangular prisms, sphere, cone, cylinder, pyramid, and cube. Now look at around you. You will see so many solid figures around you, like for example the tissue box. The tissue box has the shape of a rectangular prism. And what about sphere? Ball is like a sphere. What about cylinder? Your glue stick, the one you're using to paste something, that is having a shape of cylinder. Okay, so let's watch this video first before we go to the lesson proper.
How do you classify solids? Think about this question during the lesson. A polyhedron is a three-dimensional figure made of flat, polygon-shaped surfaces called faces. The line segment where two faces intersect is called an edge. The point where several edges meet is called a vertex. How can you classify a polyhedron? How many faces, vertices, and edges does this polyhedron have? Select your answer. The polyhedron has 6 faces, 12 edges, and 8 vertices. These are prisms. Prisms have polygonal faces. Prisms have 2 identical, parallel, polygon-shaped bases. They are named by the shape of their bases. These are pyramids. Pyramids have one base. The base of a pyramid is the face opposite the vertex where the triangular faces meet. A pyramid is named by the shape of its base. Pyramids have triangular faces. Both pyramids have several triangular faces. Why is only the second pyramid considered a triangular pyramid? A pyramid is named by the shape of its base. The base of the first pyramid is a square, so it is a square pyramid. The base of the second pyramid is a triangle, so it is a triangular pyramid. Now you know how you can classify solids.
So let's have textbook page 707. Okay, so let's read the problem all together. So what would be the unfolded and flat box of dog biscuits look like? Draw a diagram to represent the dog eats biscuits box unfolded. So here, in the figure, we are given the box of dog eats biscuits. So we are going to unfold this box. So what will it look like after unfolding? So let's start with the front side of the box. The front side of the box has the dimensions of 16 and 12 inches. So now let's draw it on our grid. So this is 16 and 12. Okay, so this is the front side of our box. Now let's go to the right side of our box that has a dimension of 4 inches and 12 inches. So let's draw it on the grid. So this is 4 and this is 12 inches. Now let's go to the left side. So the left side of the box will be equal to the measurement of the right side. Since the right side is 4 by 12, so it follows that the left side is also 4 by 12 inches. Okay, let's go to the back side of the box. So the back side of our box has the same measurement with our front side. The front side is having dimensions of 16 and 12. So same is true with our back side of the box. So that is 16 and 12. Okay, so above our front side of the box is the top side. So let's check the dimension first. That is 16 by 4. Okay, so the top side of the box was attached to the front side of the box. So we are also going to draw this top side above the front side. So this is the top side of the box. Now let's go to the bottom part of the box. So the bottom part will be equal to the measurement of the top part. So that is also 16 by 4. So this is 16 by 4. Okay, so now let's write the measurement. So again, our front side is having the measurement of 16 and 12. So this will be 16 and this will be 12. Same is true with the back side because they are equal. So this is also 16 by 12 inches. Okay, so now let's go to the right side. The right side is having the measurement of 4 and 12. So same is true with the left side of the box. It will also have a measurement of 4 and 12 inches. Okay, so of course our top and bottom will have the same measurement also. So top box is having a measurement of 16 and 4. So that will be the measurement of the bottom part of the box. So now this is our net. This will be the figure if we are going to unfold this dog is biscuits. Okay, so let's draw dotted lines where the box is folded. So this will be the dotted lines on this side, this, on this side, and on this side. So here, what will be the meaning of this folded or this dotted lines? So if we are going to fold this part of this net, we will be making this full box, or we will be making a solid figure. Okay. Now let's move on to the next example. Describe how you could have drawn the diagram in a different way. So we have many ways to draw the net of the figure that we had a while ago. So this is one example. And this is another example. Let's move on to page 708. What attributes of a solid figure could you identify in order to classify it as a polyhedron? So, when you say polyhedron, the solid figure must be three-dimensional and have all flat faces. Okay, so we have here our examples of solid figures. Which among these solid figures has flat faces? So we have here rectangular prism, the pyramid, and the cube. What about those sphere, cone, and cylinder? They are not called polyhedrons. So this is not a polyhedron. Also, this is not a polyhedron. And cylinder is not a polyhedron. Why? Because their faces are circular or rounded faces. Okay, so let's go to page 709. Everyone, I hope you're following. Okay, so this is the exercises on page 709. So number 1, explain the difference between a vertex and an edge. So here, recall the things you saw from the videos. A vertex and an edge is being compared. So what is an edge and what is a vertex? So an edge is a line segment where two faces meet. A vertex is a point where three or more edges meet. Okay, let's go to example 2. Explain the difference between a pyramid and a prism. Okay, so prisms have two parallel bases. Pyramids have only one base. And definitely you can compare a prism from a pyramid. Why? A prism has rectangular faces, while pyramids have triangular faces. Okay, so let's move on to number 3 and number 4. We are just going to identify each solid from its net. Okay, number 3. What kind of solid figure is formed with this net? As you can see in the middle, there is a square. So that is a square pyramid. Why it's a pyramid? Because the faces are triangular faces. Okay, let's move on to number 4. This figure is having two sides or two faces that are triangular and three faces that are rectangular. So meaning to say, these two faces that is triangular will be the bases. So this is a triangular prism. And why do you call it a prism? Because most of the faces are rectangles. Okay, so for your independent practice, let us check. Of course, I know that you can identify these nets directly without thinking or without the need to have lots of time. So here, number 5, the base is a square and most of the faces are triangles, so that is a square pyramid. Yes, you are correct. Okay, try number 6. So one face, the one in the middle, is a triangle and most of the faces are also triangles, so this is what? Yes, it is a triangular pyramid. Okay, number 7. Two faces are triangles and there are three rectangles. So two faces will be triangles, so this is a triangular prism. Why a prism? Because most faces are rectangles. Okay, so let's have page 710. Let's answer some problem solving on that page. So this is number 11. Which prism can be made using the net shown at the right? Okay, so look at the net. This is having two rectangular bases on the side and most of the faces are also rectangles. So you call that as a rectangular prism. Okay, number 12. Draw a net of a square pyramid that has a base that is 2 units long and the height of each triangular face is 5 units. Okay, so let's read this question precisely. So here there's a square pyramid, meaning the base is square and that base is 2 units long. So 2 units long and the height of each triangular face is 5. So now let's go to the grid. So square pyramid that has a square base that is 2 units long. So this will be our square base that is 2 units long. And it says that the height of each triangular face is 5 units. So meaning the height should be 5 units. So that is 5 units. So we can now make the triangular faces here. Okay, what about on the right side? This is 5. So also this will be made, the faces, the triangular faces. And on the bottom part, this is 5 units. Okay, so let's make the triangular sides. And again, 5 units. So this will be the triangular faces on the left side. Okay, so that's it for now. I hope you understand our lesson for today. So you are now ready to answer your exercises and your homework independently. For your questions, just don't hesitate to message us. Good luck, girls!